All right, here we have an old Philco console picked up, got given to me free, and it's in good cosmetic condition. It's got little scuffs and bangs here and there, but that's no trouble to fix. The main thing is all the veneer is good, except for two places. Here and on the other side, they used balsa wood. God, they put balsa wood on there. Oh, I don't know what's going to happen there. We'll see. We may have to strip it off and put a different material on it. Okay, the first thing we got to do is we got to get the chassis and the speaker out of there. What, Kitty? What? You coming to help? Did you come to help? Yes, little kitty. It's two. I hope when he said that it's working, it means that the speaker is good and the transformer is good. The audio output transformer, that would simplify things a little bit. Okay. Well, that's been worked on. It's been punched through a few times, but it's been repaired. Okay. We'll do a quick ohms check on it and see that the transformer. Okay, this is not the original transformer. This is a different transformer than was originally in it. And then we'll check the field coil, make sure it's okay. Now, that's very good. This has unquestionably been worked on before. This is just put in with one of these things, which is baloney. Okay. Nope. I was hoping to see capacitors. We got one capacitor there, and that one's new. But we don't have enough capacitors in there to say that it's recapped. All right, so we've got filter capacitors in there, and these are old filter capacitors, so this work was done 20 years ago or more. Because of the style of capacitor, they have not been around for 20 years. Okay, first thing we got to do, we got to see all the tubes. Okay. This is one of those Philco chassis where they wired this inner chassis first, then they had it all wired and they put it into there and wired it in. So there's no way you can get up into there without one heck of a lot of problems. Okay, so okay. All right. Now, this has got to be sandblasted. You sandblast the whole thing. All right, next day, look at this. You see how pretty it turns out once you sandblast it? You know, all of that dust and dirt is off of there. Got little places where there's some rust, but that's what you expect on a radio this old. All right, let's see. We got to get all of the hardware more or less straightened out before we start on electronics. I noticed one thing that we have here. We've got our light bulb that lights up the... Okay. Pewing! This thing actually looks like it's good. Alright, that's good. Okay, this is asshole tone. It works pretty good to clean stuff, except for plastic. Okay. Okay. That's got that back. All right, that takes care of our light bulb. See, it's got a little slot there that lights up the appropriate band when you change the band switch. Okay. Now, the tuning is pretty nice. Now, we've got, if you look down in between here, we have little fingers that are contacting the rotor and the stator, and that gets your tuning condenser to where the contacts are good when it rotates. So what we want to do is clean that up a little bit. I'm going to take a little bit of, damn, I'm almost out of contact cleaner. Okay, now we'll just take that and work it. That'll liquefy the dirt a little bit. Now I'm going to tilt this up. I'm going to put some oil on a little vernier mechanism. All right. That's doing good now. Damages. All right, here is the guts. The very first thing that has to be done is filter capacitors. We've got two of them in here. I got one right here and one right there. They were just kind of sloppily put in. All right, to test the capacitors, we're using a triplet 630. It puts 30 volts on the capacitor that's being tested. It's a lot better than these little digital jobs that put out 0.6 of a volt on the capacitor. You can have terrible leakage at higher voltages, but if you got 30 volts on it, that catches the contact potential. Breaks it down, and you can see what kind of leakage you really got. All right, so that one's in good shape. Okay, if one cap is good, there may be bunches of them good. All right, now to test the electrolytics, what we do is we connect voltage to them. Ground and plus. All right, where can I get a plus? All right, there's a plus right there. Now, okay, this power supply puts out up to 500 volts. I'm going to set it to 450 volts. Okay, it's 350. Okay, we're reading 30 milliamps right now. It's charging up the capacitors. See, it's connected to the electrolytic. See, if I take it loose, it goes up 470 volts. I connect it to the radio. We're reading 30 milliamps of leakage. Okay, that's what. See, we're going down. See, we're not going to have that kind of voltage on them in this set. In this set, we're going to have about 350 volts on them. All right, let me set her down to 350 volts. Even at 370 volts, we've only got 5 milliamps. So these filter capacitors that they've replaced are good. Okay? Now, you don't need a power supply designed up to test capacitors. You can use just your regular power supply and your milliamp meter in series with it. The main thing about having see, this power supply is current limited at 30 milliamps, so it makes it to where if you got a short, you're not going to fry something. So we don't have to fool with the electrolytics. Notice we're testing the electrolytics with the filaments not lit. No tubes in it, no filament. So all we're measuring is the capacitors in the set. We're not measuring the plate current or anything like that. Okay, this one here, somebody's replaced this one, so it's probably good. Okay. Well, let's see what we go to. All right, we're meeting 10 meg ohms. 10 meg ohms on a capacitor like that, you may as well just short the thing out. I mean, it's, yeah. That means it's got water leaking into it. It would work because it's just a bypass capacitor. But you don't know what's going to happen later on. You know, that thing can start leaking more and fail. Bypass capacitors, you don't have to worry about the value. Anything equal or bigger than the original is fine. Like this one here originally was 0.05. We use a 0.1 in here, it'll do just fine. It's just I have a whole bunch of 0.1s. And I don't have a whole lot of 0.05s. I think I got, yeah, I do. I got probably several hundred of them. They're in a different box. I buy the darn things from Mouser by the hundreds. I just get the 100 quantity. I go through so many of them. Okay. All right, we got another one right here. Okay, this one here is up inside there. It's been replaced too, but we'll check it just to see. Somebody went through this radio. But it looks like it was probably 20 years ago. That's, you know, that's not old. You know, 20 years ago is in the 90s. That was late. But 20 years is a, you know, you're getting to the lifespan of some of these capacitors. All right, that one there is over 20 megs, so it's okay. No problem at all with that. Over 20 megs. You don't have to worry about them. They'll last the life of the planet. Okay. Now, there's another one that you don't have to worry about, and that's cathode bypass capacitors. They have very little voltage across them, you know, less than 50 volts. So you put a 600 volt capacitor in there, and it leaks with a 1 meg ohm leakage. It'll last the life of the planet without any problem. Okay, here. See, this one has got 4 meg ohms of leakage. And it's on the cathode. It's cathode bypass. So I'm not going to worry about it at all. It will do just fine. See, it isn't going to have enough voltage across it to cause it to go bad. Okay. Now, we've got some originals in here. I got one right here. Let's just test these here and see what we've got. Okay, that's a 0.1 mic. Look at those beautiful things there, those little yellow ones. Right, those are so nice. Okay. They only cost 50 cents a piece, so you know, it's not like we're putting a lot of money into it, changing out the capacitors. The place where you spend money repairing these old radios is stuff like knobs and speakers and transformers. There's stuff that's big bucks. The capacitors are cheap. Even electrolytics are under $1 each. Okay. All right, we got another one. What the hell is that one? Okay, this one here has to do with volume control. All right, let's see what we've got. 20 megohms. Okay, no trouble. Dook. All right, now there's one. All right. Now that's a coupling condenser, so it has to be good. This one here is the grid coupling condenser in the audio section. Okay, that has to be good, because if it's bad, then voltage gets on the grid. Okay, 10 megs. Okay, that's no good. Okay, it has to be, we were talking about megohm impedances on a audio circuit, the audio amplifier circuit, so that capacitor has to be very good. It can't have leakage or else we'll have distortion. Just like it's... That whole thing is a piece of crap. Okay, I'm going to cut it out of there. That wire, the wire, it goes up to the grid cap. I'm going to go ahead see, it had a homemade grid cap on it, and there's split insulation crumbling off it. Okay, 0.01. And that will go over to where the other one did. Okay. That will make it. I just barely made it. Okay. Okay. That looks good. No, it isn't any good. It came loose. Just be kind of stuck on there like a piece of bubble gum on a window. And it'll come loose if it gets any stress. See, now we got it. We can't get that loose at all. It's on there good. I'll say, good grief, look at this radio. Some completely incompetent old fart worked on that radio. Look at this. All right, and that has to go through here. Okay, and that gets us our, okay, that's all taken care of. Okay, now we'll put a new cap on that and it'll be good. This is the tone control capacitor I'm betting. There we go. That goes to ground. Okay, that one's shot. It's reading 2 megohms. Okay, if it's 2 megohms, it'll go down to under a megohm in no time. And it get heated up. It goes from the plate of the output tube to ground for tone control, through the tone control. Okay, 008. All right. Okay. We got another one here, which I'm just going to bend down. There we go. Okay. I'm going to make this one here. Okay. Now we got one more. Okay, I don't know what gets that out of there. Okay. Okay, it goes up to 4 megs. What does it do? Pin 8, it's cathode bypass. Okay. No problem. Cathode bypass, there'd be no trouble with 4 meg. Okay. That's all there. All right, that's all the capacitors. That's all the capacitors. Okie dokie. What's that been? That's been what, less than half an hour to do all the capacitors and clean the tuning control. I don't know. Well, I can tell what I'm going to have to do. I'm going to have to take some of those old chassis and cut some fresh Gozantas. Okay. Here we got a Gozanta. Came off an old radio out in the shed. See that Gozanta? It's a Gozanta because it goes onto the tube like that. Okay. Yeah, it's still hot. Okay. Now, tubes. Okay, this is a radio that is going to antique store, so I don't care what kind of tubes we've got. Okay. This is original. It's a Philco. It goes in there. Okay, I need a cleaning cloth. I just got a wet rag here. I'm just clean these tubes off and make them look pretty. Okay, there's our rectifier tube. It looks good. All right, that goes in here. Okay. Now we've got R7. Okay, that is our audio tube, so that goes here. Okay, this is an IF tube, so that's got to be a 6K7. Okay, what in the hell? It looks like somebody put some glue on here to hold the top. God. See, it looks brand new. I could take that and put it on eBay as a brand new tube. Oh, doke. That'll do. Okay, next we have another 6K7. All right. Let's give it the cleaning job. That's our RF amplifier tube. Okay, that goes here. That's our RF amplifier. And then we have our mixer tube, 6A8. Okay. Looks brand new. I could sell that on eBay for brand new. No doubt there's people that do that. Polish them up good and... All right. Okay. Oh, this has to go on here. See, that's why I made it tall, and I almost goofed it. I almost missed it. Isn't it the shit? Whew. I almost missed it. Here, there we go. That's got enough. That's do. But this is a glass tube. Glass tubes do not have a shield inside, so you got to have an external shield to go on them. The metal tubes have got a shield built into them, so you don't have to worry about them. But the glass tubes all have to have an external shield. Otherwise, you'll have some real trouble. This is the wrong damn shield. I'm going to go out and get, let me see this one. Okay. That'll work. It's supposed to be square like this, but they're about 1/8 of an inch larger. Two different sizes. Okay. That's gorgeous. See, and now the Gozanto go right in here. I should have made it a 1/2 inch longer. God, how does that ever piss me off? It isn't going to fit. All right, is there any wire underneath here? I can get it. Oh, that just burns my butt. How could I have done that? Okay, let me get a little piece of wire. Yeah, isn't that enough to... I mean... Oh, my goodness. I thought I was making that long enough. All right, let me just add an inch of wire onto that damn thing, damn it. Number 12 bus bar. Okay, there we go. Okay. Now look. Okay, that fits perfect. Okay, that gets everything all hooked up, ready to turn on. Ooh, no. I forgot one very, very important thing. We don't have any cord on it. Oh my goodness, how are we going to turn it on with no cord? All right, let's see. Where does the cord go? All right. There's the old cord. There's the old cord right there. Okay. All right, now I'm going to check those line capacitors. I've got one of those crappy line condensers there. All right, they're way the hell up there. Okay. All right, now, okay, I got to get a cord. Okay. All right, let's see. That's 1, 2, 3, 4, 5, 6. Okay, just goes to there. Okay. Okay. Now we get, okay, let's see, fuse. You always want a transformer set, you always put a fuse. Always put a fuse on a transformer set. When you're soldering on these fuses, not recommended, of course, not recommended, go fast like that. See how fast it was? It just heats up, solders, cools off. If you take any time, like using too small of an iron, you'll blow the fuse using a soldering iron. So you have to do it quick. Best to use a fuse holder. If you use a fuse holder, you'd mount it somewhere over here and string wires and all that. I don't bother. I got to make money on this. I can't sit here and fiddly doodle around. Got to make money on this. You can't make money if you're going to fiddle doodle around. Okay. Okay. Yeah. Okay, got a fuse. Okey-doke. Okay, that takes care of the fuse. I'll write on there. All right, we are ready. Oh, I forgot the 6F6 or whatever the hell it is. 6F6. Off. Okay, looks brand new. That's our power tube. Okay. Now we got our rectifier. I thought I felt it break. These damn things cost about $1.50 each, and they don't last very long, really. You know, maybe 100 joints or so. So you're paying a penny a joint using a soldering gun. I remember back in the '60s, I was paying $25 a joint. Best deal I ever got. I got 3 pounds for $300. That was pretty darn good buy. But you know, you look at that stuff. It's nothing. It was crap compared to what you get now. Oh my God, now. Whew. I mean, you get an ounce now would do what a whole pound would do back then. And you're paying the same damn amount. Now you're paying $300 an ounce. But you get the same amount of kick out of it. You know, just be common sense. Don't drive. See, shit, it's got powdered solder in there. It's flux and powdered solder. And you stick that iron down in there and it tins it up perfectly. All right, let me get the speaker. All right, before I'm going to skin the wires, go ahead and test the damn thing. Be just my luck to have it bad. Oh, it ain't reading. No, it reads. It's good. Okay, that one's good. All right, how about the field coil? That's the one that'll be bad. Yep. Yep. Yep, it's bad. It's bad. All right. You know, this speaker, all right, did we luck out? Okay, let me just see if we lucked out. Ah, no. No. That's one wire, and that's the other. It's. I can tell it's. This isn't where it is. It's down inside there somewhere. No. All right, I'm going to save the transformer, though. The transformer's good, but the speaker itself isn't worth. I'm not going to bother with it. That's probably why the guy gave the radio to me, because the speaker was bad. God. Hey, you get it free, you don't necessarily get something good. Shit. That goes in the junk. All right, up in the attic, let's get another speaker. So it's got a couple holes in it. Yeah. Got a big one right there we got to fix. Okay. Now I need a couple of shit metal screws. Okay, and that should be good. Okay. Okay, this is contact cement. Been sitting down there for 2 years, so I don't know if it's good yet. We'll see. Thick. Look how thick this stuff is. Oh man. Yick. Gick! What do I wipe it on? See how it liquidates it? This damn crap liquidates just about anything you can imagine. I'm down to the last drops in there. I got more cans of it out in the garage. Okay, now, since we've changed this from a field coil to a permanent magnet type of speaker, I got to put a power resistor. I've got to have a power resistor in here for the take the place of the 6F6 is what, pin 3 is the plate? I can't remember. Okay, I got to find a resistor. All right, now I'm going to put that resistor in here. It goes between this and this. He put it together with friction tape. Friction tape, hell. Oh boy. Look at that. That's that old cloth friction tape. Damn. Alright, now. I'll just fit. Alright. Now, we can't let that touch that cover, so what I have to do is hold that down. What I'm going to do is I'm going to take a little disc capacitor and put it in there and use it as a tie point. Very, very rugged capacitor here. See, if I solder that to there, okay, and I can take this see, that capacitor will keep that from moving, and yet it won't affect the operation of the radio at all. Probably make it work better. Okay, that takes care of our speaker. Okay, now the next thing to do is to connect up the speaker itself. All right, and this is our repair. See, that's perfect. I'm just going to temporarily hook these on. I'm not going to fasten the speaker permanently until we get it mounted. That ain't working. Damn, there we go. All right, let's see. Let's go with the ohm meter. Okay, we've got some terminals on the back here that have to do with the antenna. Both of them have coils, so we'll have to see. I don't know if one of them's shortwave and one's the other, or whether, you know, it just, there is no telling. So we'll just have to try it and see which one works. Okay, let me get the scope going. Okay, now what we're going to do is we're going to put the signal generator on the antenna terminal, what we think is the antenna terminal, and we'll put the scope on the grid of the RF amp, and we will see which terminal gives us a signal there, and that will be the actual antenna. Okay, so all the way counterclockwise is the broadcast band. Okay, let's see. Now I want to. Okay, see if I tune the signal generator, we can peak it up right on the. For each, that's reading 760. Okay, and there. That's 850. Okay. Okay, that's all the way up. That's reading at 1500. Okay. And all the way down. 517. Okay. So this input is. Now let me go to the other one. Okay. That gives us about 2 divisions, and on the other one, we're getting about 4 divisions. So definitely the other one is better, okay? So I'm going to set the signal generator. I'm going to bet, it doesn't say anything about what the frequency of the IF is on this thing. I'm going to bet it's 455. So what we'll do is we'll set the generator to 455. 455. Okay, I'm going to feed that into the input. Okay, that looks good. Uh-oh. Uh-oh. Okay, first thing we'll do is pull the audio tube out. All right, let's fire it back up. Okay, now I've got the audio amplifier tube out. So, all right, we still got the hum. Okay. So the first thing we got to do is straighten out the mess. This has got something to do with the filter capacitors. Okay. Let me tilt this up. Okay. It would really be best if it was the other way. It would be best. See that tube sticking up out of there? If I tilt it, it hits that tube. Okay, we're sitting on the dial thing and a one of those big can capacitors, so that's completely okay. All right, now, okie doke. All right, let's fire it up and scope. All right. Okie doke. Good look. Okay, I want to see what that is. Before I stick my $2,000 scope on there, I'm going to see what the voltage is. Right at 250 volts. All right, that looks good. Woo! All right. Okay, that one's got a pretty good amount of ripple. Okay, let me get is that capacitor down in there. It's not leaking, but it doesn't have any capacitance. Okay, let me get another capacitor and stick it in there. All right, I got a 22 at 450 here. All right, we'll let it warm up. That's the problem. You know, when they built this radio the first time, they would crap if they saw this is bigger than those cans that they've got. Those cans that are 1.25 inches in diameter and 4 inches tall, and this is more. The can is only like 8 microfarads, and this thing's 22 and more voltage. Oh, they would just, oh. I remember when I was a kid, you know, looking for stuff to use in the transistor radios, just trying to find electrolytics that would be on the order of, you know, what you'd use in a transistor radio. And there just wasn't anything like that back in the early 60s. The electrolytic capacitors were all huge. You can't heat a big terminal like that with these little piddling soldering irons. You know, these are made for circuit boards. To work on these radios, you've got to have the power of one of these guns. This is 250 watt, and it'll let you heat these big connections without overheating everything. All right, now power on. Okay. Total silence. Okay? Now, that takes care of that little problem. That does not take care of all that scratching and crackling, and the volume control is not working. All right, let's, what I'm going to do is I'm going to take the meter and measure that control. If the control itself is shot, that could be the problem. It looks good. All right. Let's go ahead and juice it up again. It could be a bad tube. Okay. Power on. All right. Now the volume control has absolutely no effect at all. What a good idea. Something had a charge on it. Damn it. It still had voltage in it. Ah. Hell. What the hell's got voltage in it? It doesn't have voltage because it discharged it through me. It's got a phono input. Isn't that crazy as hell? All right, we're gonna take that out of there. Ground is right there. Okay. It's got a phono input. Well, we shall eliminate the phono input on it. There's no reason to have that. Okay, now the problem is that the cat. Did you do that? Oh, heavens. I put that wire back on there. I put it in the wrong place. You know, I knew I had that wire long enough, and that extra inch was right there. I put it to the wrong terminal. Arrgh. I did it again. I'm working. I don't have a schematic of the thing, so I have to just go by how it looks. All right. All right, that should do it. When we can do that, we know we got signal going through it. All right, let me get an antenna. Okie doke. There's this antenna.
As soon as we go off here, I think Bregman hits a home run to get a Forster last night.
Okie doke. Okay, let me get generator. Okay, 460. That's it. Alvarez just hit a home run. The Astros are playing. Alvarez just hit a home run. Okie dokie. Okie dokie. All right, that gets the radio part of it going. Now we got the cabinet. The cabinet. Whoever did this put balsa wood here. This is balsa wood. I mean, you can stick your thumb right into it. All right, I'm going to see what stain will do on it. It doesn't really matter if it looks good. Let me get some sandpaper and sand it, and then we'll try some stain on it and see what it looks like. All right, let me get a little bit of stain and just try it on there, because if it doesn't look good, I'm going to have to peel it off of there somehow. All right, this is just some cheap hardware store stain. It's called Special Walnut, which is just kind of a light walnut. All right, let's see what happens. Ooh. All right. That needs to be darker. Okay, let me get dark walnut. All right, this is dark walnut. It should be closer to what this other one is. Okay, that's going to do okay. All right. Whatever glue, it looks like he stuck that stuff on there using liquid nails. Liquid nails. Oh well, hey, it was free. I didn't have to pay any money for it, so, you know. This one's not for my collection. It's just going to be sold for 50 bucks somewhere. There's the kitty. Okay, I'm going to let that harden some more, dry some more. Okay, now I'm going to use this walnut brown spray to make this match a little bit better. All right, I've got to make the speaker mounting. This is the original speaker, and it's an odd size. It's 11 inch, not a 10 inch and not a 12. So we got a 12 inch that we got to put in there, so I got to make a panel to do that. So what I'm going to do is just cut a piece of plywood here. Okay. The hole locations are vertical, which means the top hole goes here and the side holes go the other. Now for the hole, I'm just going to go around. It is not important. I think 3 of the holes are marked, but the 4th one is not there. All right, now go. Okay. There was a piece of fuzz that was there, and the pencil had went on the fuzz. All right, so we need to cut the big hole, 4 littles. All right, the littles we'll do with this. Okie doke, that will take care of that. Go. All right, that's going to go. All right, now I've got to... Get that other radio. Okay, we've got this thing completely cleaned up, stained, and we just want to go ahead and put clear lacquer on it. Got a powerful fan blowing the air through the room, so it all the fumes go outside. All right, so we're mounting the speaker board here. Everything you get is jammed and not fitting, and oh man, this is the one I need. Okay. Now, that gets that put in. All right, I'm going to have to take the grinder and cut these threads off of here. another one. Get 4 or 5 more so that when they all fall on the floor, you just keep pulling more out. All right, that's got the speaker mounted. One right here. Okay, and we'll put one right here. No. Boy, it's pretty bad. I'm going to do a little. Some neat stuff. This is UV stuff. It's super glue that hardens instantly when you hit it with a UV light. Some of it comes in these little contraptions. It's got a little, like a hypodermic needle on the end of it. It's hell to get it to come out of there. I think they only put a few drops in this tube. You think you're getting a bunch, but it's really just maybe 10 or 12 drops out of that whole thing, and it's like $15 for this thing, but it gives you that cute little ultraviolet light that goes along with it. It's a lot better to buy the damn separate light, buy the separate light and that big bottle like I used there. Get the big bottle of stuff and get that separate light. Looks like a little flashlight. All right, next we have to solder the wires. All right, now that gets the speaker wire put in. Okay, the next thing we've got, all right, we're going to stick built-in antenna. Okay. Okey-doke. There. Here. All right. Damn, I shocked the shit out of me. I don't have anything plugged in. It's some kind of a static electricity. I shocked the crap out of me. Okay. Okay. See, we're just going around here in a loop. And we're going to bring it over here and fasten it to the antenna terminal. And that's going to give us a built-in antenna. It doesn't do any good to have more of an antenna than this in Houston. There's so much noise that you can't pick up shortwave and stuff like that. There's a few really strong shortwave stations that you can pick up. But the noise level in Houston is so bad. All the damn industrial crap and the street lights and oh hell, every damn thing in the book making noise. and all you pick up is buzz and hums and cracklings, and that's just disgusting. Okay, that gets us our antenna. Alright, next thing to do is put the knobs on it. Alright, now what I got to do, take these knobs, one is hitting down under there. There's rubber gaskets, the chassis spacing gaskets that are missing. Philco is one of those radio companies that like to use that squishy rubber on everything. They had squishy rubber under it. They had squishy rubber under the tuning condenser, between the chassis and the tuning condenser. That squishy rubber, and that squishy rubber turns into goo over the ages. It just stops being rubber, turns into gush, and perfect. Okay. All right. See, it gets that stuff in those in the cracks out of there. Got that built up crud. Okay, looks just like new. The next thing that we've got to do is to plug it in and give it a try. Okay, I've got a. Okay, let me get this. We'll move her over a little bit. Okie doke. All right. Plug her in. Turn it on. All right. On. Okay. It needs to be up.
By Coca-Cola and by Oxy, Capacitor, working together to
so that we can go help the American people.
House Republicans plan to meet Monday to consider new candidates. The U.S. court lifting restrictions on the Biden administration.
That right there are these LED light bulbs. This is a bad time of day. We're 4 o'clock in the afternoon, or you don't get much on the short wave at 4 in the afternoon. Around 7 or 8 o'clock tonight, or 9 o'clock, it'll get better. Good enough. Good enough. Get out of here. Okay, we'll get $50 for it, and that's good enough. That's I'm not going to do a lot of work for a $50 radio. $50 radio. Okay, I need to get a rag and clean a little bit of dirt off of that bottom of there.